Hello everybody and welcome to VMware vSphere with Kubernetes Day 2 operations. I'm one of your hosts today. My name's Simon Conyard. I work as a Senior Technical Account Manager in the UK and Ireland. You can see details for my blog and my Twitter handle there.
So I'm also your second presenter for today. My name's Dean Lewis and I'm based also in the UK as one of the cloud management specialists in the VMware organisation.
So today we're going to run through some hopefully important and timely information for you. What we're going to kick off with is we're going to set the scene around VMware and Kubernetes integration. We're going to talk a little bit about VMware and Kubernetes offerings. Then we're going to dive straight into Day 2 stuff. So we're going to talk about access controls. We're going to talk about storage and networking, image control. What is it? Why is it important? We're going to cover resource management and then also monitoring and fleet management.
And then, of course, we'll cover off a little bit of footnote. So basically, everything that we've not been able to capture in this session. We are kind of aiming at the level 100 if you're used to the VMware terminology. And the reason for that is we're giving you the areas that you need to look into as a data operations as a VI admin at a vSphere level, moving into Kubernetes world. And unfortunately, there's just way too much to go into in a 45 minute session for the UserCon today. But if there's anything that you'd like to see from us in the future in presentations, then please do get in touch with us during the Q&A in this session. You can use that through the platform itself and we'll answer the questions live, or by all means get in touch with us over Twitter as well. Okay, so a little bit of scene setting. I'm going to try not to bore you too much with these slides. But why are we moving towards this cloud native world? Why is Kubernetes becoming a thing within VMware? Well, as we all know, kind of the applications changed. You know, everyone throws out the big names out there like Netflix and so forth. And I'm going to build out this slide very, very quickly. But we're all used as a VI admin to applications consisting of a few VMs. So application VMs, database VMs, web VMs, that typical three-tier application. But on the right-hand side now, we can see applications moving towards distributed system architecture. And what does that really mean? It's not something that's new into the industry, but it is new in terms of how the technology implements it. So the virtual machines don't go away. We can see them being shown there at a VM level, maybe bringing in GPU resources. The database space still being virtual machines. But then at a services level, we may introduce Kubernetes clusters that run our applications, have a distributed control plane for those, have multiple nodes, GPU nodes in there as well. And then we go across really to some of the really great buzzwords, such as serverless, so bringing functions and event-driven architecture into your environment as well. This then kind of makes up that distributed system because you've got multiple technologies that have been all laid together and need to work in harmony. So a very quick overview of the VMware offerings. This is by no means a comprehensive list, but just gives you a little bit of scene setting for today's presentation, some of the technology we're going to talk about. So announced at VMworld, we have vSphere with Tanzu. So that's Kubernetes baked in, native within the vSphere platform itself, native integration at vSAN to provide you functionality such as vSphere pod, vSphere operators, namespaces, and so forth. And then we enhance that even further with the VMware Cloud Foundation piece, which we'll talk a little bit more in a few of our slides. We have Tanzu Kubernetes Grid, which is an enterprise Kubernetes runtime designed to provide organizations with consistent, open source, aligned, multi-cluster operations across your software-defined data centers and public clouds. So that's running the Kubernetes on-prem in your VMware environment, but also in your public cloud environments as well. And then finally, although we're not really going to touch on it in any detail, but again, if you've already looked at some of our marketing, some of our products that have been out there, some of our rebranding, just touch on it today. We've got Tanzu Kubernetes Grid integrated. It's a mature service using NSXT and vRealize products. And if you were a previous user of it, or you were following us really closely in the early days of the container world, then you'll know that as our former product, Enterprise PKS. Okay, and then very finally, so we're going to show you some demos today, which is fantastic. It's not going to be death by slideshow. Our environment is a VMware Cloud Services, a VMware Cloud Foundation Services environment with Tanzu enabled. And again, just to kind of run home, what does that native integration mean? So we've got that Tanzu runtime services baked in at the hypervisor level, and we're also bringing some hybrid infrastructure services there as well. So the typical service that you expect to already be available for virtual machines, such as running VMs, service running containers, service, storage services, networking, and registry services as well, which is seen by the agenda. We're going to touch into a little bit more detail. But again, there's a whole host of other options that you'll need to start to come to terms with and get engaged with in the future as well.
That's great, Dean. Thank you for the overview. Yesterday I was a vSphere admin. Today my organization is telling me I'm still a vSphere admin, but I've also got to support Tanzu Kubernetes as well. What do I need to know to be successful in that role?
So that's exactly what this presentation is about today, Simon. At a high level, we're going to go through the theory that you've deployed as a day 0 and day 1 operations, vSphere with Tanzu, maybe even VMware Cloud Foundation with Tanzu. And we're going to talk about those day 2 operations. So why don't you get us started, Simon, talking about access into the environment?
Oh, I should have known that you were just going to hand this straight back to me, Dean. Thanks. So, Dean, the way we assign access in vSphere translates to the way that we assign access in Tanzu Kubernetes, in that we can create roles in vSphere and then we assign permissions to that role inside of vSphere. That role is then allocated to groups or individuals, and those groups or individuals are then linked to inventory objects such as folders or resource pools, or perhaps even virtual machines. Well, now that can include and encompass namespaces and the resources that exist under those namespaces. What we also have to consider, though, is much like when we provide root or admin access at a virtual machine level, that allows the rights for an administrator to manage permissions and to allocate their own admin access. When we provide administrative access at the Kubernetes cluster API level, that's going to allow someone with that access to create their own security policies and also create access for users outside of the VMware SSO domain. Okay, there are a couple of very useful links that are on this slide deck that talk about how to grant developers access into Tanzu Kubernetes clusters, and also going into a little bit more detail around how to use pod security policies with Tanzu Kubernetes clusters. So I wholeheartedly recommend that you look at reading those documents as part of your day 2 preparedness. So Dean, can you tell us a little bit about Kubernetes integration with vSphere storage, please?
Sure. So I've got, as we can see on this title slide here, very helpful. I've got 3 quick slides. I'm going to throw a lot of information at you, but we're going to go into a bit of a demo as well. So first and foremost, the thing that you need to understand is some storage primitives within Kubernetes itself. So for those of you that are the vSphere administrators today, this kind of concept of storage class really works the same as storage policies inside of vCenter. What it's doing here is it's a way for developers to be able to deploy their applications, and in their deployments, they would reference needing storage. They would build what's called persistent volume, so you can store your database files in files that are outputted for logs and so forth. And you would reference a storage class to create that volume and your need. Within that storage class, it has a number of capabilities, and also the storage system that it's going to go off and request that the storage links are created. In our environment, it's obviously going to be vCenter and the vSphere storage. And then that's going to create the backend VMDKs or file shares if you're using vSAN 7 and above with file share capability now as well. And it's a really powerful automated way of using storage. What does that actually look like? So if I move into the next slide, so we've built integration and extensions between vSphere into Kubernetes to create cloud native storage. So what does that actually look like? So at the top here in the blue in the diagram, we still have that Kubernetes environment. The pods for the applications are going to be created. We're going to speak to what's called a CSI driver which is defined in the storage class itself as to which driver would be used. That driver will then go off and speak to the CNS control plane, which is part of vCenter. And then vCenter will determine those commands and then create either the block or file-based storage on the back end. And we can consume stuff like vSAN, vVols, VMFS, or NFS, for example. And as you can see, there's a couple of capabilities there on the right-hand side. So we offer file-based persistent volumes on vSAN, which is available in vSphere 7. We support vVols at the moment, and we'll be expanding that capability going forward. We also support encryption and snapshots. And one of the important things, well, volume resizing. So if in your application you create a volume at 100 gig, and you need to extend that, same as you would previously in virtual machines, you can do the same as well. And then one last slide for you. So how do we make this even better and more powerful? Well, you have two options. You create a storage class that points directly to a VMFS volume, for example. But the better way to do that is to use storage policies. So we use the SPBM, which you all know and should love, 3 vCenter that's available today. And within your storage class, you can actually reference that storage policy. And then vCenter will dynamically create the files or blocks in the correct storage based on its policies within vCenter as well. Now, I admit I've thrown a lot of information at you there very, very quickly. So we're going to move into a demo now, and I'm going to show you an application that's already been created, what that looks like, and then what your view is as a VI administrator, which hopefully should tie all of that together.
That's great. Thanks, Dean.
Okay, so we're in the vCenter interface. As mentioned, we've already kind of set up the workload management side of things. That's a day 0/day 1 operation. I've created a namespace, which is really simple. You click new namespace, give it a name. There's nothing set up in here, but most importantly, we're going to be running a native application on the ESXi host itself. So the first thing I want to show you in the storage side of it is I want to kind of link those storage policies that are used to in vCenter back to what happens in the Kubernetes developer world. So we're going to go into policies and profiles. I'm going to go to storage policies. I'm going to click new VM storage policy. And again, this as a VI admin shouldn't really be any different for you. I'm going to paste that name in there that I've already got, and we'll see that name appear elsewhere. I'm going to use tag-based placement rules because you're going to see in a moment that I've tagged my virtual machines. My data stores rather, for workload management. So you can see there I've got an NFS data store, and we'll click next. You can see storage compatibility here, and then we're going to click finish. And then the next thing we're going to do is going to go back to the workload management interface. I'm going to go into that namespace that I've already created. And we've got a number of policies here. So Simon later on is going to go into a little bit more detail on some of these policies. We skipped over kind of creating permission side of it, but you do it here, create permissions. I've already given myself administrator permission there. Again, same as adding permissions you used to through the vCenter console anyway. Going to add storage policy here, because at the moment, when I log in, I would be unable to deploy anything to the storage policies. And we can see I've already got one for BusyBox that I created before. And the reason why I've called that BusyBox is I'm going to deploy an application called BusyBox, which is just a really lightweight image for this demo. So we've added the storage. And when that reloads, which it just has, I'm going to quickly go to edit storage as well, because I did miss out a key important piece there. If I move down on there, show the available data stores again. And then finally in the edit limits piece, which again Simon's going to go into a little bit more detail on, we can see storage, we can do a limit on everything, or we can click open, and any policies we've given particular access to, we can also add limits into those, and we can change it from megabytes to gigabytes as well. But we're going to leave that at the moment. And the other storage policies that we're going to see. So I'm going to move into my Kubernetes developer mode. So we've got a SSH connection. We can see the different contexts that my user accounts available at the moment. So we can see I've created a namespace called BusyBox. And we can see that it runs on this Kubernetes cluster, which is local to me, given the local IP address space there. We can see another namespace, which you'll have noticed before, called Livefire. But the one we're interested in is this BusyBox one at the moment. And the first thing I'm going to do is I'm going to show you get storage classes. So remember, when we talked before, storage class is the equivalent storage-based policies. It's how do we create things within the Kubernetes world. So we can see at the moment, I've got the BusyBox storage policy, the one I've just created. It's passed through that CSI driver as the provisioner. You can also use one called WCP storage policy, and that's because I'm looking at the admin account. And I've got a view of a couple of different storage policies that are available within the Kubernetes environment within vSphere. However, whilst in the BusyBox context, in this namespace where I'm going to create my application, as in a developer type mode, if I try to use this WCP storage policy, because it's not being added into my namespace, I would be unable to create anything in there and actually get an error message. So within my YAML folder here now, I've got 2 YAML files. So what I'm quickly going to do is I'm just going to show you what the contents of that file is for the PVC. So the PVC is the persistent volume claim. That's the name for giving persistent storage within Kubernetes itself. And it's nothing special. We've set some labels here. We've set the name of it. We've obviously told it what the annotation is. So what storage class we're going to use. So it's that BusyBox storage class. The access mode and how much storage we're going to request. And then if I do a quick cat on the BusyBox pod itself as well. So this is actually running the pod. So again, this is a lightweight pod. I've given it some labels so we can see it in vCenter. We can tell you what the actual container is, where we're going to download the image. So you'll learn about that a little bit more from Simon later on. The commands that it's going to run, and then the volume that it actually creates itself, and links it to that BusyBox PVC, which we've seen above. So I'm going to do kubectl create file BusyBox PVC YAML. And that did not work because I need to specify the namespace on it. Because if you remember before, when we created that policy, if it's not there, it doesn't work. So that's a really good example of it kind of showing the RBAC model in place as well. Now, if I do it with the namespace on it, we'll see that that persistent volume is now being created. So very quickly to verify that, we're going to do kubectl get PVC, and again with the namespace on, because the namespace is important for the RBAC model. You can see there it's there, and that bound basically means it's worked and it's called off to the provision as well to create it. And then if I go up on my commands, I'm cheating a little bit, I'm going to create that pod as well. And again, that pod's going to fail because I don't learn from previous mistakes. And there we go, see the pod as well. So if we do kubectl get pod in the namespace, native app. And that's created, and we see it's pending at the moment. And the reason why it's pending, it's going to pull down the images from Google and so forth, and it's going to link everything together.
Is there a way we can watch the progress of that?
Yep, so we can do kubectl describe. When you describe the pod, give it the pod name, and then against the namespace. That will give you a one-time view, and it will show you the event. If you just want to show it change status, then one of the things you can do very quickly is just run the watch, and then the N with the 2 on it, it's normal Linux command, and then provide your kubectl command with it as well, and that'd refresh every 2 seconds, for example. But again, remember, you're probably not going to be doing this as the VI admin. It's probably going to be developers doing this, but it is handy to know exactly how they interact with this part of the environment.
So that's great. So I've got a question then, Dean.
Yep.
You say I'm probably not going to be doing this as the VI admin. So what will I see as the VI admin, given what you've just run?
So that is a fantastic question. And as you can see there, I've just been booted out of the session and back in again. Okay. So we're going to refresh this page. So we can see now we've got a persistent volume claim against my storage, which is amazing. You can see there we're using 1 gig of storage as per the volume created. And we can see I've got a pod running now as well. And this graph's just changed up. So what we're going to do is we're going to quickly go into the monitor interface. So we can see Kubernetes events coming through, everything that was going on with myself. We can see anything that happens within vCenter as well, that's linked to it. So we can see here that, BusyBox is now running because the pod is running on the ESXi host itself. We go to storage. So we're going to see that storage policy that's being created. Again, we can edit it from this view rather than summary view. We're going to see any config maps that are available. I've not created any config maps. We'll see the default secret, but again, you could have additional secrets there. And then the best bit is we're going to see the persistent volume claim. So from BusyBox, you're going to see the name of the PVC. I just called it BusyBox PVC, you see. You can see the full YAML file that was used to create it. You can also see the persistent volume name that's back-ended within vCenter. Because we know vCenter likes to use these things called UUIDs, which are not readable from a human perspective. So we'll click View Volume. View the YAML. So we can see the YAML that's in place. And again, if we did that describe command on the PVC within the Kubernetes command line, we'd actually see the same information. If I click persistent volume name, that should change my view. And what's happened here now is it's changed my view to the host clusters view. Clicked on the cluster where it's based, clicked on monitor, took me to the cloud native volume section here, and we can see that put volume, and it's actually just kind of put a filter in there for me as well. One of the things that's really cool about this section, so I'm just going to make this smaller if I can. Oh, and like all good demos, things don't quite drag as you'd expect. Let's go back into that view. So we can see it's here. We can see it's compliant against the storage policy in place. We can see it's accessible and the volume ID as well. And then if I click see all of the labels, we can see those labels that I set before. So we can see the name, we can see the location that I set, just to show again it's a native, it's all links are native. I click this little details tab as well, which is fantastic. And one of the best bits, I think personally here, is we can actually see what pod it is linked to as well. So we can see it's being actively used. Why is that important? Well, you may have PVCs that are created but not linked to pods yet, and you may not need to know whether or not you can delete them. You can see here it's identified as vSphere workload because again it's native. We've also got the kind of this basics view as well, which just gives us that kind of information from before. Today we're just kind of looking at the block view, but you've also got the file view. And then the final thing that I want to show, why is this important? I hear you cry out and ask, Dean. Well, because before these types of integration were available, go back to older versions of vCenter, if you looked at the file view in your data store itself, you would have to figure out where's it created, what folder. We can see here I've got a BusyBox for my app running, my pod, but not a virtual machine. So does it create it in there? Well, we can see some things, but there's no PVC file in there that looks like it needs to be created. So then we move down and we move to the FCD, which stands for first class disks. And we actually see all of these different PVCs files, which are the VMDKs, because remember, we're working in block. But how the hell do you relate any of these randomized numbers to what's running your pods in a Kubernetes environment? In previous versions, before we brought all of this together in vCenter from 6.7 onwards, you weren't able to do that. It made it very complicated. But now as the VI admin, you've got all of that information to hand. Okay, so that concludes the storage demo. Thank you very much.
No, thank you, Dean. Thanks for the demo, Dean. If I've understood that correctly, what you're saying is that I can use those storage-based policies that I use to manage virtual machine storage for managing storage in my Kubernetes environment as well.
Yeah, exactly that. You can pass through that greatness of the storage policies that you've been using to control virtual machines into the Kubernetes environment and expose it through a storage class that can be consumed by your developers. And this means your developers don't need to know or understand what's going on the storage backend or any of the fundamentals. They just request essentially the capabilities that they want, which is really handy, really great from both sides.
Perfect. What about networking? Does that work in a similar way?
So Simon, it's almost like you've seen the agenda and know that my next slide is going to be networking. Okay, so going back to what we talked about at the start, where we kind of covered those three main areas of VMware and Kubernetes offering, I've tried to kind of really simplify this because it does get a little bit complicated depending on what it is you're deploying. So at a high level, we've got vSphere with Tanzu. So this is the ability to deploy the Tanzu Kubernetes that integrated into vSphere, into the hypervisor itself. And we have some open source projects which are designed by VMware. So that's Antria for pod networking and so forth. You can go out to other services such as Calico. However, if you have NSXT available in your environment already, you can also integrate there for node networking, for the load balancing of the KX management interfaces. That's kind of the APIs where everything gets done in Kubernetes. And the same for pods as well. For microsegmentation, again, you're going to have to look at those open source projects for that at the moment, or you can again bring it to NSXT. But this is kind of one of the real benefits for using VMware Cloud Foundation with the Tanzu services. As you can see, it's really simple there in the middle. It's NSXT for everything. You do have the ability for load balancing for pods and the ingress to use other services if you wanted. So I would call out here maybe NSX Advanced Load Balancer, formerly known as Avi Networks, if you wanted. But essentially, it's that one-click deployment that you're getting through VCF, and it ties all of these software-defined stack together very, very easily. And then we move into Tanzu Kubernetes Grid again. So again, a couple of different options there. The ones I want to call out is load balancer case management. Now, again, this is where you're deploying Tanzu Kubernetes Grid into the multi-cloud environment. So the options are going to vary a little bit depending on which cloud you deploy into. Load balancing for pods. So again, if you've got it within VCF, you could use that NSXT. But essentially for multi-cloud, it's bring your own load balancer of choice. For ingress, you could fall back on the OSS project contour, which has been designed and given to the CNCF by VMware. And again, you've got a couple of options there for pod microsegmentation. And I just added a little footnote at the bottom that this table obviously doesn't cover all available options, configurations. What I'm going to do is going to move into a demo now. I'm going to show you our VCF environment. I'm going to show you an application that's been deployed in a Tanzu namespace within VCF. And then I'm going to show you some of them constructs that are automatically created for you within NSXT, i.e. making it really quick and easy for you to manage as well.
So Dean, now we're in our demo environment again. Can you show me what I need to know from a networking standpoint, please?
Yeah, so to change things up a little bit differently now, what we're actually going to do is I've deployed an application on a TKG environment, and that Tanzu Kubernetes Grid is deployed under the vSphere Kubernetes namespace of Livefire. And then as we can see, there's a virtual machines being deployed there, because we mentioned TKG is used for multi-cloud deployments. That's why we're using virtual machines for this one. But I thought we'd move away from that running natively on the ESXi host just to show something a little bit different. So I've already deployed an application. So I'm just going to show you that in its namespace. So we called it Demo App. It's going to run the Hipster store, which if you've kind of followed Kubernetes stuff before, you'll have seen previously. We see we've got a number of kind of IP addresses there that are local to the hosts and the container networking in place. And what's special about this application, we're going to use the load balancer as well. And the load balancer is going to be provided by NSX. So we go kubectl get service in our namespace of demo app. And in the return here, we can see the number of cluster IPs against the services. And we can see here we've got the external front end service against the load balancer. We've also got that external IP address. And just for all good demos, I'm going to show you that quick hipster shop as well to show you that it works the way that you expect. It's nothing special. We've kind of all seen a website before, right? And I'm just going to move back into that command line and show you what makes it special with that load balancer service as well. So I'm just going to go to buy, I'm going to go to my demo app YAML file. And very quickly, I'm just going to search for a load balancer service. There we go, with a capital B on it. So how have we actually specified that? Well, all I've done as acting like the developer is I've changed here to say that for this service that I'm creating, the type needs to be load balancer. And what's actually happening on the back end here is within our TKG service, we've deployed the NSX container plugin, or NCP for short. And as you can imagine in Kubernetes, that's a number of container services and pods that sit there, and it looks at kind of the application deployment processes going on with Kubernetes. If it sees services that it's been set up to handle, such as creating load balancers, it then interprets those commands, those YAML files, sends off the information to NSX, and NSX will build those resources we need. So let's move into the NSX interface now, Simon, and we'll see what that looks like there. So to
load balance the application, the developer just has to say,
yes,
load balancer. That's really cool.
So as we've seen before, just save some clicking about, I've gone straight to where it is in virtual servers, but we've gone to networking, we've gone to load balance services, and we're looking at the virtual servers itself. So we've seen the IP address that we were given before. So here's the IP address being shown. Here's the port. We were mapping to port 80. Here's the server pool that's been dynamically created as well. And we've identified the Kubernetes, vSphere Kubernetes namespace and the fact that TKG cluster is called prod. Bit of a mouthful to say there. And what I'm also going to do very quickly for the rest of this demo is just click on view statistics as well. We're going to see a little bit more about the virtual service. So we can see here, this was kind of information about my session as I was clicking through it a couple of seconds ago. If I click into server pool, it's going to show you some more statistics around the actual server pool on the back end. And then finally, we can click through to server pool members. And at the moment, because the way the application is designed, it's actually going to show you the IP addresses of the TKG worker nodes where this pod is running as well. And then again, we can see more stats per node as well, which is really funky. But the main thing is this being done dynamically on itself. And there's a lot more extensibility from that point of view that a developer can request for that load balance service as well. So are you doing, TLS handshakes? Are you passing that through from the client straight through to the application? Are you breaking it? Are you doing multiple ports? And also as well, one of the things that we're not touching on today, but as we know in NSX, we get microsegmentation as well, so we can do that. And then just as one last click thing, where else can we see some integration here? So we can also see that in the trace flow as well. So where we can see virtual machine, we'd actually select port or interface, select virtual VIF, and then here we can see a number of the domains and so forth as well that have been set up. Now that gets a little bit more complicated the more that you build that up, but actually as you can see here, we can see I've got this one highlighted. It calls out VMUG native app, which was the vSphere resource namespace. We see that it's called BusyBox, and as you can imagine, that is actually our BusyBox instance that we created earlier today. So I'm just going to click that BusyBox, which finds my IP address that was there. We're just going to select a random virtual machine in the environment as well. So let's do this Redis cart. So actually that is a pod running for my application that I've just deployed. So we're kind of just kind of running it as we see fit. So the Redis doesn't have an external IP address, so that's not going to work. So that's fine. So let's try the control plane. There we go. So this is one of the virtual machines running in the TKG cluster itself. You can see here it populates that information for me. And then what we'll do is we're just going to do a quick trace on this. And hopefully, like all live demos, this should return very quickly. And as we can see now, that's built up a little bit of a map showing going through my BusyBox where it's been built, that segment that was dynamically created by NSX for it, into the tier 1 domain, up to the T0 and then back down as well through the next tier 1 and into that virtual machine itself. And then here at the bottom, we obviously have that full path of the traffic as well. And then, of course, in today, we're allowing that traffic because in my NSXT environment, we basically just allow everything to talk to everything because we don't really care too much. But if we went into the security and set some firewall rules, we could also block that traffic and then it would show that it's blocked by a rule as well. That typical firewall features that you're all kind of used to. But for me, this is kind of one of the really cool things of NSX when it comes to container networking as well. Okay, so that kind of concludes the networking demo. Moving on.
So we've obviously covered very quickly there what's available to use a vSphere administrator and some of those integrations that you get out of the box when deploying Kubernetes with networking as well. As you can imagine, for myself, I really like the integration there with the NSXT and things being populated dynamically. So moving on, one of the really important things for us being a vSphere admin is ensuring that we use validated and security approved within our organization images for virtual machines. Simon, could you talk to us about that in the Kubernetes space, please?
Yeah, absolutely. So just like we use content libraries to manage what templates are available or what OVFs and OVAs are available to deploy into the environment, we can use Harbor to do that in the image space for Kubernetes. So what that means is that we can come up with, on a project by project basis, a list of approved images that can be deployed into an environment. We can upload those images into the Harbor image registry and then at the time of deployment, the developers can reference those approved images from the Harbour image registry, rather than referencing perhaps an online image repository, or maybe referencing someone else's image that's available on GitHub or wherever. We can bring control of the images that are being deployed into the environment. So image registry capability is included with VCF with Tanzu. Out of the box, you get that image registry kind of integration with simple setup from a one-click simple setup inside of VCF. There is also an open source version of Harbour, which includes the capability to sign images with Notary, and also the capability to scan images for CVEs with Claire. Okay, Dean, so we spoke a little bit about Harbour and we spoke about image registries. So how about we take a look at that in action? And just to change things up, I'm going to have you drive.
Yep.
So first things first, which is an awful phrase. My colleague, John Harvey, he hates that phrase, but there you go. If you select our Region A01 cluster,
yep,
and then have a look under Configure,
yep,
you'll see that there's an option further down for image registries.
yes.
Now, if we want to enable the bundled native version of Harbour that comes with vSphere, all we have to do is click that Enable Harbour button.
Yep.
It'll tell us what storage. In fact, go ahead, click it. It'll ask us what storage we want to deploy it into. You can see again, we're talking about storage policies. So from here, you can select the WCP storage policy. And if you click OK here, it'll go through, and how about that for a simple deployment, right? It is now deploying those Harbour resources. It's going to create a namespace and deploy those resources into it. In fact, if you look to the left for your host view on the left-hand side, can you see that it's already created a new namespace?
This one here, the VMware
Yep.
system.
If you expand that, you'll see eventually that it'll start populating that namespace with the objects that it's creating for the Harbour image registry. So maybe we'll take a look at that.
See that in the Kubernetes events as well.
Yep, perfect. So you've already got it open. We've got the Harbour, a Harbour repository here that's the CNCF version of Harbour. Yep. So this is what it looks like. When you deploy Harbour, this is what it looks like when you log into it, with a few exceptions between the native version and the CNCF version, but broadly speaking, we're looking at the same environment. Now, to use this, what we can do is you just deployed BusyBox into an environment, right?
Yep.
Okay, so let's create a new project and let's give it a name, BusyBox. Yep. So you see there, big button, lovely stuff. We're going to call it BusyBox. We're not too worried about controlling access, so we're just going to let public access to this environment. So anyone who knows that it exists can pull images from it, and select OK. And then that's going to create our project. And if you click into our project, we can see we have our project. They've got one administrator. If you select repositories, you'll see there's no images associated with that repository at the moment. Now I'm going to ask you to go into the command line here, okay. Dean. So can you open up your PuTTY session?
Yeah.
So in order to use the Harbour repository, we have to make sure that there are some there's a Docker certificate location. So can you change directory for me?
Yeah.
So if you change directory to /etc/docker /certs.d, and then hit return on that. And then can you list the contents of that volume?
Oh, I can indeed when I press the right command, Simon.
Okay. Okay, so here we are. We can see that inside of our Docker certs, we already have the appropriate folders created to use our CNCF Harbour repository.
Yeah.
If you type in Docker images, you can see that this local machine is aware of only a single image type that's been downloaded. Now what we're going to do is we're going to download BusyBox using the Docker tools. We're going to tag it so that we can use it with our Harbour repository, and then we're going to push that image to the Harbour repository, and then we're going to use it. Sound cool?
Yep, let's go for it.
Cool. So if you type into your command prompt here, docker space pull space busybox, because we're not really worried about where it's pulling it from. We could specify a library to pull it from, but I'm not worried here. We're just going to pull from whatever's considered to be the latest. And then space, we need to type in here a double dash, disable dash content hyphen trust equals true. And that's just because we're not using signed. We're not pulling this down from a signed repository at the moment. So if you hit return on that, you see it's using the latest, it's pulling it from its library. And again, now if you type in Docker images,
Clicking to the latest.
There you go. You can see that we've got our latest BusyBox repository.
Yep.
Now we need to tag this BusyBox image for use with our Harbor repository.
Okay, Simon, I've just cleared my screen there quickly just to keep it nice and neat. Do we want to continue?
Yeah, great. So can you list the contents of the directory again, just so we make sure we get the image repository correct?
Yep.
And now what I'd like you to do is we need to tag that BusyBox image that we downloaded appropriately for use with our image repository. So Docker space tag space, and then the image that we downloaded was just called BusyBox. Yep. So if you type in BusyBox,
yep,
and then a space after that, and then we're going to use our Harbor repository name. So it's harbor-01a.corp.local, and then we're going to put / on that, and then the project name, which was BusyBox, and then a / on that, and the image name, which is BusyBox. If you press return on that, and now if you run a Docker images, you can see that we have an appropriately tagged copy of the BusyBox image that we can upload into our repository.
Yep.
Okay. Now to push that repository, we first need to make sure that we've got a logon. We logged on to our local image repository. So if you type in docker login space and then harbor-01a.corp.local again, Harbor without a U.
Yep.
And then return on that. You see it's authenticated us against stored credentials. So now we know we're authenticated to the correct repository. Our last step here is to push that image to the appropriate location. So if we run the following command, we're going to run docker push space and then the harbor-01a.corp.local / busybox / busybox.
Yep.
Yeah, you're getting ahead of yourself there.
This is what it's like being a VI admin. You want to do everything fast, right? And now I can't spell BusyBox. There we go.
You can't spell BusyBox.
Okay,
if you hit return on that.
That's the project name, and then this is the actual image name is the second BusyBox,
exactly.
Right?
Yep. Okay, there we go. So it's now pushed that image into our BusyBox library. If you go back to our browser and refresh this view, so you can refresh this view. Yep, there we go. You can see we now have our BusyBox image.
Yep.
That's great. How do we use that? So if you go back to your PuTTY session, very simple Kubernetes command that we can run here. Now, am I right in thinking we've got an appropriate namespace that we can use?
Yes.
Okay, great. So what we want to do is we want to run the following command. kubectl, so yep, run BusyBox, and then space / image, and we're going to tell it where to find the image. So that equals harbor-01a.corp.local, and then / our project name, which was BusyBox, / our image name, which is BusyBox. Let's say we want to run this pod interactively. So we're going to do a space -i, And then we need to say the namespace. So what namespace could we use for this, Dean?
So it'd be vmug-native-app.
Okay, so /n. Sorry, -n. And then that name. I think it's vmug rather than vmg.
My keyboard skills escape me.
Just as well, we've got 2 pairs of eyes, right?
Exactly.
And then if you hit return on that, this is going to not only create, but it's going to launch us into the pod. So we're now using the pod interactively.
Yep.
Now we can see if we're using the pod interactively. So say, for example, if you run an IF config, we can see here we are in our pod virtual network adapter, and we're on this 10.244.0.238 IP address space.
Yeah, fantastic.
Now, how does that look from Harbor again? If you flip back to Harbor and refresh this view, we can see that the image that we've uploaded has been pulled once.
Okay, Simon, thank you for that. So as we've had the ability today to control images through things like content library for when we deploy virtual machines, it sounds like using Harbor, it gives us the perfect way to manage images that are going to be used by our developers within our new Kubernetes environments that we're deploying on top of vSphere. And this really leads me on to the next subject. As we deploy these new Kubernetes constructs, obviously we really need to keep on top of resource management. So could you talk to us about that, please?
Yeah, that's right, Dean. So in the same way that a VMware administrator knows that if you want to scale resources at an ESXi host cluster layer, you really only option available is to purchase ESXi hosts and add those into the cluster. So we scale those ESXi hosts with adding new host objects into our available cluster. When we look at managing virtual machine resources, we apply maybe reservations, we maybe look at applying limits, or deploying virtual machines into a resource pool with those reservations allocated. We can do exactly the same with the VMware namespaces. So we can look at allocating limits, we can look at allocating reservations to what a VMware namespace can consume. And then if we look at the left-hand side of this diagram, the resources that are deployed within the VMware, the vSphere namespace environment, we can look at scaling those with Kubernetes commands. So we could look at either looking at the limits and reservations allocated to the individual resources that are deployed within the namespace from a Kubernetes API standpoint, or we can look at scaling out those deployments and adding multiple components in that are operating underneath that namespace resource. Now, it gets a little bit more complicated when we look at the right-hand side of the diagram, where, for example, instead of deploying applications directly into a vSphere namespace, we're deploying Tanzu Kubernetes grid clusters or virtual machines underneath the vSphere namespace. Now, in the same way, if we want to look at scaling those resources, we've got 2 options, right? We can either deploy larger virtual machines, or we can look at deploying additional virtual machines in the form of controller or worker nodes. And then in the same way that on the left-hand side where we have namespace resources, we can look at utilizing the Kubernetes commands to either deploy multiple copies of those resources and load balance between them, or look at editing the limits and reservations allocated to those resources. We can do exactly the same under a TKG cluster. Does that make sense, Eugene?
Yeah, okay. So we really need to pay attention to where we're deploying our applications then in the vSphere environment with the Tanzu Kubernetes services. And it sounds like maybe we have to take a little bit more care and thought about if we're using TKG, especially in that multi-cloud type environment as well. But it sounds like really, it's as simple as managing, what we're used to with virtual machines.
Exactly that. There's no need to complicate it. Certainly the vSphere namespace and virtual machine management layer, there's no need to complicate it more than that. We are left with our very similar options that we've had for decades. We either scale up resources in adding more resource to existing nodes, or we scale those resources out.
No problem. And could you show me a quick demo of that in the interface for the vSphere namespace, for example, and these resource policies?
So Dean, we were talking about scaling and resource management in the previous slides. So I'm just coming into Virtual Center now to give you a bit of an overview of that. If you were to say select the live fire namespace that we have on the left-hand side there, if you go to the summary view of there, you can see that we've got that nice tile there called capacity and usage, which gives us a nice big button to edit the limits. So if you click on the edit the limits, you can see here we go. We can attribute a namespace that we've deployed natively within vSphere, a limit in context of megahertz or in gigabytes from a memory standpoint or gigabytes from a storage standpoint. And I think if you expand that storage element, you can see we can assign a limit against a particular storage policy as well as an overall limit for a namespace. But what does that mean when we're talking about a TKG cluster, for example? TKG clusters are obviously defined by virtual machines. They're deployments of virtual machines. And we can see underneath that live fire namespace, we have a TKG cluster that consists of 5 worker nodes and a single control plane. If you jump into our PuTTY session here, could you type in the command to show us an overview of the Tanzu Kubernetes clusters?
This is where I probably spelled it wrong. Hey, look at that, I got it right for
There
one.
you go. So that gives us an overview from the PuTTY session of our worker nodes and our control plane nodes that we've deployed to make up this Tanzu Kubernetes cluster. Now, I think we're in the right directory here, but if you just list this directory for me, there should be 2 files here. So there's a cluster prod.yaml, which is what we've deployed right now. So could you cat that file for me?
Yeah.
Now what we can see here is this is the YAML that's been used to create my Tanzu Kubernetes grid cluster here. We can see it's got a count of 1 control plane and it's got a count of 5 worker nodes. So how do we go about adding an additional worker node into this cluster? Well, it's pretty simple. We just change that count from 5 to say 6. Now, to make things simple, I've got a separate file in here called cluster-prod-edit.yaml. If you open that file up, you can see it's an exact copy of the file that we looked at previously that we used to deploy the cluster, but we have a count of 5 workers. If we change that to a count of 6 workers and save the file, I was going to see if you're going to get caught out with exiting vi there, but you know. So here we are. We have our configuration file that now points towards a Tanzu Kubernetes grid cluster of having 6 worker nodes. To deploy that, to scale that cluster out, all we need to do is apply that file. So if you write your kubectl and then apply, and then a file, because we're going to point to the file for the configuration, and then point towards the cluster prod edit YAML, a few things are going to happen. If you hit enter, yep, sorry, in the namespace, you're quite correct. So if you click enter on this command, we can see that it's reconfigured. But interestingly, what we should see happening inside a virtual center, and if you just, those eagle-eyed among us will see, it's deploying an OVF package into the cluster and it's going to create a new virtual machine. Yep, there you go.
Yeah,
as Dean's highlighted.
Yeah, I can see that happening now.
And then when that's finished deploying, we will have scaled our cluster.
So what we should be able to do then, Simon, I'm guessing by the power of intuition, well, let's put a quick watch command on this as well, because we talked about it earlier in one of the other demos.
Yep.
So we'll watch this for every 2 seconds. So we have 1, 2, 3, 4, 5, 6. And we can see there that's the virtual machine being created at the moment.
That's correct.
And obviously it's still deploying at the moment, but Tanzu Kubernetes Grid, I would imagine, would start to schedule pods to that node as soon as it's available.
Yep, it handles the creation of the virtual machine and the elevation into the cluster all behind the scenes. So there we go. that's how we scale a pod, and that's how we can manage resources that are attributed to a namespace inside a virtual center.
Okay, fantastic. Thank you, Simon.
So there we go, Dean. That was a quick overview of how we can scale and manage resources inside of our vSphere environment. What about monitoring? Can you talk a little bit about that for us, please?
Yeah, certainly. So how do we figure out where my containers are running, especially when I'm a VI admin? So this is where vRealize Operations Manager really comes into its own, because that provides you that infrastructure up view from your Kubernetes environment from the vSphere level. So let's go straight into a demo to look at that as well. So to save some time, I've already set up the connectors into my environment. You just follow the great documentation produced by our team. I've added 2 Kubernetes clusters in here. So I've added my management cluster and a cluster where I'm running workload. If I click between them, I can see summary of the nodes that are happening, what the health cluster is. You can see there's no problems happening here. That's obviously because me and Simon run a tight ship here. Moving down, you can see, click through your nodes, and then there's a lot more information here to pick metrics and so forth as well, and pick pods and containers and things. But for me, one of the best things about this, again, is you're seeing Kubernetes view here, not kind of, okay, well, how does that relate to my vSphere environment? So one of the great things about this, outside of monitoring on a Kubernetes level, is when we go to environment view, when we actually start to tie that back down to our vSphere environment. So we can go through the management pack here, or as we can see, because I'm going to kind of cheat, we get a custom group called K8's World. You see all of our objects that are managed under that Kubernetes world and those adapters. So I'm going to click in my Kubernetes node. I'm going to click on this first node in our environment. And then we can see all of the objects that are available. So not only can we see all of the containers that run on that particular node at a moment in time, but also we can see the vSAN cluster that it's part of. We can see any resource pools that the virtual machines are part of that run the Kubernetes services. And actually, if I click in virtual machine, we'll see the virtual machine that it's tied to as well. And we can even see that this is tied to a load balancing virtual machine that's deployed as well. And then, as you can imagine, we start to build that up with metric views as well. Typical CPU, the same way that you monitor a virtual machine within VROPS that we're all used to. So that, again, is just a very quick view of what do you get with the integration to VROPS. It's that infrastructure up into the Kubernetes view, tying it from what's happening at vSAN to the virtual machines, the storage level, into those environments that are running those pods and container services.
So that's fantastic there, Dean. So that means using VROPS, we can link our traditional VI desktops right the way down to our Kubernetes namespaces and resources running in those namespaces, and provide dashboards in the SOC around that.
Yeah, exactly that, and that's what you get from the VROPS piece.
Fantastic.
So we'll move back into the presentation now and continue on.
Well, that's great, Dean. So that covers off monitoring with VROPS. But what about sort of multi-cloud Kubernetes cluster management? What can we do in that space?
So this kind of really brings us towards the end of the presentation now. We have holistic cloud management across native platforms, or fleet management, as I was told over the weekend. We have a SaaS-based offering called Tanzu Mission Control, and that gives you visibility and, most importantly, policy management across holistic Kubernetes platforms. That's kind of the real key piece, is that policy management. And you also have some secondary functions as well, such as being able to deploy Tanzu Kubernetes grid environments into AWS platforms as well. Gone into the footnotes there, but don't worry, we'll move over into my environment. So this is Tanzu Mission Control. Because it's SaaS-based service, it is based online. We have this thing of kind of cluster groups, that's grouping your Kubernetes environments together. If I click into the Tanzu one here, we're going to see those same Tanzu Kubernetes grid environments that we're looking at in VROPS. We can see that a couple of information about them. We'll click into one of these now. We'll see some high-level overview information, lots of green ticks, fantastic. We'll see information about the nodes. We'll see the namespaces piece as well, especially where applications are deployed, and that's going to be quite key in a moment. Click into the Yelp environment, for example, into the namespace rather. We can see the workloads that are running in there and if they're actually up and running as we expect.
And I can see it's pulled the labels through from the YAML that you use to deploy that application as well. So we're tying the front end back to here as well.
Yeah, exactly. So, your developers should be using labels to easily identify stuff. They actually use labels to select how services run in the environment as well. So it's very key for us to have that information there. We have this ability to set up something called workspaces. So a workspace is an organizational structure rather than thinking about cluster levels. This is kind of where you're going to have your developers working across multiple clusters, deploying applications where they need to. And then we can control what we call group namespaces across multiple clusters as well. And those group namespaces, how we're going to tie together that organizational control from a policy management point of view as well. So if we go into the Tanzu workspaces, again, we created one here called VMUG Test. You can see it lives on one of our TKG clusters. And if I click into there, we see at the moment I haven't actually deployed anything to this environment, but we're going to show where that kind of really comes from. So in the policy section, this is kind of the real key, powerful part of TMC itself. We have the ability to set up templates for all policies, but I'm going to jump straight into assignments. I think we're all okay with the idea of templates, especially after this session as well. So we can control RBAC and access into our clusters and workspaces. We can control image registry access. So what image registries are in use at policy level by our developers. So Simon talked earlier about using Harbor for our image policy. So we can actually see here as well that I've set one up. If I go to the workspace view under Tanzu, we can see an image registry policy there, and we're actually pointing to that Harbor image that we were using earlier on as an image registry. So network.
Okay, so I can configure it as a policy object so that developers using that cluster in that workspace can only deploy from those image registries.
Yes, exactly that. And that obviously gives you security and validation on the images that are being used in your environment as well. And ensuring that they're not circumnavigating the Harbor image registry services that you've set up as a VI admin, Simon.
Okay, cool. Good to know.
Getting ahead of myself there, so I was on the networking space. We're able to set network policies. So here I've allowed everything, but you can typically imagine, you can allow between pods, deny traffic, deny all traffic, for example. We've got security. We can set up quotas, and then again, for anything that's kind of out of the box or custom to your environment as well, you can set up custom policies and custom resources as well. We're able to add insights to that as well. So again, because this is kind of a vanilla environment, there's kind of nothing really showing us a problem there, kind of applying those policies I've put in place. And then the final thing in this kind of whistle-stop tour in Tanzu mission control is inspections. So we have the ability to run inspections across clusters as well. So we can select a cluster. We can select the type of inspection, so we can check its conformance to official Kubernetes specifications. We can check against the CIS benchmarks, and also we can run one called Light as well, which is about functional operations of a cluster as well. And that really just kind of ties the Tanzu mission control piece together. It's around, the main thing to remember here is SaaS-based service, and it's for those of you running multiple Kubernetes clusters, regardless of what platform they're on, whether they're on vSphere, whether they're in your multi-cloud setup. It's giving you that single pane of view, but that policy control across them all. And then if we move back into that presentation, that really rounds things off nicely for us in footnotes. So we've covered a lot. There's a few things that today we've not had time to talk about. So, using vRealize Network Insight for Kubernetes integration for monitoring that flow of traffic beyond what you get in NSX, especially for security planning as well. Tanzu observability, so wavefronts, that's looking the opposite way from VROPS. That's looking from the application usage down into the infrastructure environment itself. So that's really pulling out some deep metrics into those applications that are running. Tanzu service mesh, so again, policy management from network layer, security layer across multiple clouds. Project Octant, friendly UI for managing your Kubernetes cluster, especially for those of you that kind of not okay with the CLI. It's definitely a good way to kind of get into viewing Kubernetes environments. Project Valero, so that's offering backup of items inside of those environments. And Project Contour, which is a high-performance ingress controller as well for passing traffic through into those container pods. So thank you very much from myself. Simon, I'll hand over to you for your closing remarks.
Thank you ever so much for joining us today for this session. Hopefully you found that interesting. Any questions, feel free to reach out to Dean and I on Twitter. Thank you very much.